Hi, I'm Duncan Buell. I teach computer science at the University of South Carolina, and I have been asked to talk about the opportunities and the prospects for computer science and computer science degrees in the next several years. This is something that I'm generally very happy to talk about because the opportunities are simply wide open. The Bureau of Labor Statistics is forecasting 3 jobs for every university graduate over the next 10 years, which is just enormously good and way better than almost anything else that you could look at for somebody who's going to get a university degree. And the nice thing about computing is that you can do computing anywhere on almost any topic. So the things among the things that I talk to students about is what do they do besides computing? What's their second love? Where do they really want to go? If they really enjoy going into business, they should think about getting a minor in business and plan to start their own company. If they enjoy linguistics or dance or music, all of these applications are ordinary, reasonable applications because computing simply lives everywhere in the world today. And another thing that I think is nice about computing is that the people who do it generally really like their jobs. We get to play with great technology. We get to play with a whole bunch of new toys every 3 or 4 years, and it's hard to get bored. It's frustrating sometimes when you have to keep learning new things to keep up with the technology, but it also means that because things change, you don't spend 20 years doing the same old job. You've got to learn new technologies, new programming languages, new display devices, new applications. We didn't have the internet 20 years ago. We didn't have Facebook. We didn't have Twitter. We didn't have GPS systems. We almost didn't have mobile phones 20 years ago. All of this requires huge software enterprises to let you do what you want to do, to create new ideas and new ways to link people together. When I look at what the opportunities are, again, it's all over the map. Computer security is a huge topic today because we have literally tens of millions of computers around the world. They're all linked, they're all networked, and a great many of them are vulnerable to attacks, and we seem to have way too many people trying to attack your computer, trying to take it over, either just because it's fun for them or some malicious person who's going to download something that will erase your disk. Most of what we actually need to do in computer security, we really already know how to do. We just haven't done it. This is the big problem. The computing industry is driven by the pressure to get the product out faster than the competitor. So things get out into the marketplace before they've been completely vetted. And unfortunately, software is a really difficult thing to write. We don't seem to have gotten all that much better at writing good software. So no matter what we do, we need smart people to be able to design packages, to plan how information connects to other information, so that we can have secure systems that actually work, and so we don't get the infamous blue screen of death every 30 minutes or so. Another area that's just huge right now are web applications like Amazon or eBay. The tendency right now is to move all of the client applications to a web browser. So you're doing a web application on your desktop, and that code is running on your machine. That's the interface to somebody else's back-end database. The web application has to run on anybody's browser, so it's got to be compatible with all the different browsers that are out there, and even with old versions of browsers, because not everybody will have updated what they've got. You've got to go over an unreliable network. You've got to make sure it's secure if you're going to go buy something, because you don't want credit card numbers flying over the internet to be intercepted. And then at the back end, you've got a database, and if you're Amazon or if you're Netflix, you're keeping track of what your customers are buying, so you can suggest other things for them and say, why don't you buy this? If people who bought this product before also like this product, and suggest things. Netflix just finished a competition for the best algorithm to do this kind of thing for their movie people. If you liked a certain list of movies, maybe you'll like another list, and they will suggest those to you. All of this is software, and much of this is new software. It's not the way the world was 25 years ago, when everything ran literally on one computer inside the machine room at some company. It's happening everywhere. At the supercomputing conference 3 years ago, the winner in the high-end computation conference started with the computer, the main computer in California, the data in Korea, the display computation done in Germany, and the display was actually done back in the United States. They literally did a high-end computation around the world to produce a huge graphic display of the Northridge earthquake. This is just too exciting to not want to do. Another area that is certainly a growing part of computing is robotics and robotic control of things, robotic assistance. The Japanese are putting a huge amount of money into robotics because their population is aging, and those of us who are baby boomers may need or may want robotic assistance. Somebody who's 20 may want it only to get the Coke from the refrigerator so they don't have to get up in the middle of the television program. But the technology for doing robotics has improved to the point that devices are small enough and they're cheap enough and they draw a small enough amount of power that you can produce programmed robots that will actually manipulate things for you, pick things out of the refrigerator and look for you, and listen to what you say, provided you program them to listen to what you say. And along with this also is the whole world of embedded and mobile devices. Somebody is going to make the next $50 billion by making the iPhone equivalent, that is, the standard iPhone that runs anybody's browser, that connects to anybody's telecommunications company, and does everything that you want with a handheld device that's a browser and an internet connection and a phone and a music player, and has no restrictions. Right now we have a bunch of these different devices out there, and it's not entirely clear which one is going to wind up winning, but somebody in the next 5 to 7 years is going to come up with the device that becomes standard, and there is just a vast fortune to be made in that, and then there's a vast fortune to be made in writing all the programs for that as well. So we use these robots in our upper level robotics class, and the Defense Department is building a robotic mule that will carry a 150-pound pack and walk along uneven terrain. You can kick it and it'll jump sideways, but it won't fall over. It'll go up and down hills, it'll walk over gravel or rocks, and still carry the pack so that you can carry a heavier load further. And this is what is exciting, I think, about using the technology is if you get a good idea, like Facebook, you can start a company, you can build a company with nothing more than the idea and an office and an internet connection. You don't need a huge lab, you don't need years of research, you don't need years of FDA approval for a new drug. You really just need a good idea and the ability to get the software written and to get the idea out to the people who might want to buy it. So I think the opportunities are endless, and what I try to convince people is, especially students, don't look at your first job, look at what you're doing 5 years out, 10 years out. Where do you want to be? How can you position yourself to take advantage of this kind of technology that's just changing very fast? And then how can you jump on some piece of that technology and make it your own?